I'm just getting sorted for scraping the bearings on the headstock. I actually cleaned up a load of Chris's scrapers and sharpened them up, but they've all gone back to him. That's one I picked up in a car boot sale, I think. It's got some notches out of the end there, so I've got to try and get rid of them. That one was from a car booter. That's a homemade, well, they're both made from files. And then that's another one that was an eBay find. It's been pretty crudely ground. It's never had an edge on it looking at it. So I'm going to clean these up best I can and see how we get on. Just got to keep working that till it gets to the edge and gets rid of them nicks. I'll put a clamp on. Well, that's took the notches out of that. I've done a 3000 grit on the bottom. Oh yeah, cut my finger. And I haven't got a diamond hone that will work around that edge easily, so I've used an ultra fine carborundum stone. No idea on the cutting angles yet, so it's going to be a case of suck it and see. So yeah, feels sharp. Not going to do the hairs on the hand yet though. No. Right. Well, I've just gone over and cleaned off any marks on it and the debris, so I've got to put a thin film of bluing on it. I'm using my finger on the basis if I can't do it with a roller, and I've only got to do it a few times, I think. I'm wondering whether a cloth wrapped round it with bluing on it might work, so I might try that in a bit. I have read God knows how many pages of threads on cleaning up and dressing basically new journals. Very little about cleaning up and re-scraping old journals, sorry, bearings. Much of the stuff has been related to much bigger Babbitt bearings in the region of sort of 18 and 20 inch diameter shafts or upwards, and most of them at that sort of size are spinning turbines and the like, so they're several thousand RPM, and very few, well in fact I've not found any references to actually how the finished bearing face should look on a print in terms of points per inch contact. Generally I've found they're saying 75 to 80% contact across the width, so it's not just touching on the outside edges or in the middle, but nothing about whether the surface is supposed to be smooth or pocketed for oil. So it's all a bit of a sort of not so much a guessing game basically. It seems that there are as many ways to do it, but the key thing is that you've got to have reasonable contact. Now the basic principles I'll talk about when I'm sat at the desk and I can show you some diagrams, but as I understand it, this thing sits on a film of oil once it's running, so the actual contact is minimal. It shouldn't be any, it should be an oil film, which is basically what you're looking at with linear bearing on the ways. But everything I've read specifically on spindle bearings for plain Babbitt type bearings, they all feed the oil from either the midway or the top half of the bearing. I haven't found I haven't found a single reference to a Babbitt bearing where the oil is fed via wick to the bottom, which is what I've got. So that changes a number of things, because the key issues are the oil gap, which is the gap between the journal and the idea of the bearing, which is determined by the diameter, the oil viscosity and lubrication method, and the RPM. That's the first thing. And then the second thing is, as I say, the actual, so if you move away from viscosity, the other issue is the RPM that's required. Lower the RPM, bigger the tolerance for diameter and oil gap. Most are fed, as I say, from the top, and a lot of them are actually sat in a bath of oil, so for all intents and purposes it's flooded. So again, trying to find something which is directly relatable to this application has been, well, nigh on impossible. I haven't found anything yet. I've found stuff which is related but not directly, or completely unrelated but an interesting read. Which leads me to believe either it's not that bloody critical, and as long as it's a surface which is good, the oil wedging will appear, and I'll talk about that in a minute, or it's a black art and everybody does it differently, which I'm tending to err towards. When I talked to Chris about this very early on, he was concerned that the oil lubrication would be insufficient, but acknowledged that at 70-year-old there ain't that much wear in it. Now, all the references I found to lathe headstocks all talk about, when they're related to split bearings, Babbitt bearings, they all talk about having shims between the top half and the bottom half of the bearing, such that you can set the gap between them according to your wear level, i.e. when it's worn you can reduce the shim thickness. This lathe didn't have any shims in it, and there was around about 3.5 thou lift. So that leads me to believe that either it's, well, I know it's been in, somebody's been into it before, but either it was scraped such that it didn't need any shims and it was considered bad form to give it them, or something else. Chris, when I started talking about shims, Chris pulled a face and said, oh, that's a bit ropey doing it that way, scrape it right first time. So the jury's still out as to which way that is. There's a thread I've started on Practical Machinist, albeit nearly a year old now, and there's some interesting stuff towards the end, towards the bottom of that, and I've contacted the guy who put the post on to see if I can get any more info. Right, I'm going to lift this up and print it. Right, if I don't wallop the camera with my head, that should be a reasonable view. I have cleaned these out. Yeah. Now what they're talking about is a sort of 45-degree rub to avoid a false print putting too much ink down. Now I've using the thrust bearing to set the distance, because that's ultimately how it'll be, because I know that the journals are not perfectly round. There's a degree of taper, I think it's on the front one, not huge. So, I don't know whether you can see that. Bring you down. If we take the front one, I can see some contamination there. Scrape. Same at the back there. That's not so bad. Now, so these are the wick holes, and from what I've read, the gap either side of that wick hole is basically tapered into it so that it doesn't shear the oil off. It encourages the oil to pick up. So I'm not expecting to see a much of a print across there, but if you can tell there's no print around the edge there, and nothing around the edge there. And then that's pretty much duplicated on the back. So what I'm going to be trying to do, and I'll get my marker pen and I'll mark around the area. I'm going to try and scrape it for contact, and I'll bring you back. Right, you have to excuse the crappy drawings. What we've got at the moment is something in the region of this. So we've got contact in this region and this region. And on the top half we've got a lot of wear, basically at that angle. If this is the front of the lathe, and that's working against tool pressure, so it's as you'd expect. So that's the top half of the bearing. Now when the bearing cap is sat on, I don't get a print, so I know that there's excessive wear there. So the job to do is basically to remove material from the underside of the cap. Having measured what it is, that's what you take off, and then you scrape it to give you your contact and your clearance. And that's where you would put the shims. I'm not decided yet on the shims, but I've got to get the bottom half, so I'm happy with it. Which, as I said, is basically getting some contact area around here. Because of the way the oil's fed, as you can imagine, if the wick's here and it's running that way, it's picking up oil here and transferring it up and out. What I don't want is the oil just pissing out either end. So what I believe I'm supposed to be doing is, on these sections where you can see there's no contact, I've got to drop the rest so that these areas then become good contact. That way the oil's got to squeeze past it before it leaks out, so you have the lubricating effect, as opposed to at the moment it's basically worn, so it's a nice squirt line. So I should imagine that's very well lubricated. So that's the first job, get those knocked back so that I've got a print that goes from edge to edge. In terms of the zone inside the red, I'm not going to bother scraping until it starts bluing up, but ultimately I need to have a taper from the wick out and in, and then also on these lines here, because ultimately there could end up being, if I'd end up shimming it, I'd have to take this, you can see there, take that area in, so again the raw edge of the top half doesn't act as a shear to break the oil film. Now that's, if I run my finger over that, I can actually feel, and you can just see a witness, so that has already been tapered in. It's not as pronounced on the inside, and it's the same on that one. There's a noticeable not ledge as such, but witness. Now that could be, that's where the spindle runs, and it could be wear, I don't know. I'm not experienced, so I can't base it on experience. But anyway, bring you back in a bit. And one of the things that I've read said that you want to try and avoid any grooves going, if you like, around the circumference, so they want to be at an angle to it. That helps distribute the oil, which I guess is similar to doing straightaways. So what I'm trying to do is go at that angle, then change direction and come back another way. And I'm using the bottom of I'm using that as the cutting face. I've obviously, when I've ground or sharpened it, I've straightened up the edges and it's still digging in, so I think it needs a negative rake to cut it and not dig in, which would be like interestingly, I watched a video on YouTube of I think they're Indian guys, or Pakistani, somewhere out in Asia, and they were scraping quite a big shell, half sort of size of the whole headstock, but they were doing it with what I can only describe as what looked like a piston ring, sort of about so big diameter, maybe 1/4 inch across, and they were just scooping it out like that. Yeah, quite impressive. Love watching the films of the way the Asians do stuff. They kind of like work on the basis of as long as it works, it doesn't matter how you do it. I'm actually deburring with this cloth as well as cleaning it off. I'm not doing it with my fingers, I've already tried that. I doubt if I'm taking more than 1/10,000th of an inch in a scrape, which is fine. Like I say, slow and steady. I'm just going to respread the ink. Sorry for my bumps. So that's mainly printing on that side now. Yeah, well, bring you back when I made some progress. Well, I've had various interruptions, but over 3 hours, this is the progress we're at. Still going for alignment, and I'm still, or I am now, 0.03 millimeters high, and I'm 0.03 millimeters forwards. What the hell's that? That's I think 1.1 thou. So what I'm doing is I'm leaving the back end and I'm just dropping this front down, and all the time it's, well, you can just about tell, but it's bringing the print out all the time, and I'm dropping this side as a majority. I'm actually leaving this at the moment and just taking it out of this portion, which is causing the spindle to move back, which is bringing my front back alignment back in. The last measurement I did it, we are now 6/10 forward and 4/10 high. So we're in we're in shouting distance now. So I'm now going to start, after this, concentrating on getting bearing now. And keep monitoring it every third cycle. I'll bring you down so you can see a bit more detail. So the back one I've done nothing with, which is why it's pivoted on the back. So I'm expecting, as I bring the back bearing in, the height will raise. So I want to get it down to sort of midway in the tolerance. So that would be, instead of 0.015 mil, I'll aim for something like 0.01. The front, all I've been doing is taking away this side to basically shift it over and drop it down. So there's a lot of work to be done to get the bearing right, but alignment first, bearing second. So I'll try and set you up so you get a view and see the actual scraping I'm doing. I've taken to using this shorter scraper because I can control it a bit easier. And it's whilst it's a soft material, trying to do it without getting a burr. Remember, you don't want to be using a stone on it to remove any burrs, because you'll end up leaving fragments of stone in there. You've got a better view than me because I'm trying to look past the camera. And then I'll just work along this bottom edge a little bit, help it drop down. There you go. That's the following print. So we just carry on now. I'll even that out a little bit more, and then I'll put the spindle in and then run the gauge across and see where we are. I mean, I'm taking off a very small amount each time, so every third measurement it might amount to 3/10 back here, and I've only got sort of 4 or 5 to go at. And we're checking the vertical alignment again. So that's centered the run out. We'll then slide that down to the other end. I'll zoom in a bit. Not the sharpest of images. But remember, we're looking for this to be 1 division lower than it is. Excuse my bounce. And that's exactly 1 division. So bring that out. So basically, when I spin that round now, you can see it hovering just below, flickering either side of 1 division below. So vertically we're spot on, which means what's key now is if any material I take off the bearings has got to be even both ends for it to drop parallel with its current position, as opposed to dropping the back or the front. Next job, spin it all around, check the front. I'll bring you back in a second. So horizontal position, we've centered it up again. Getting all sorts of parallax issues looking through the phone. That's centered up there. And scoot it along. Make sure the needle's settled, and then we see where that evens out. I would say that that is reading 1 3/4, 2 3/4. So that's still 2 divisions, so we're half a division up, which is 3.9 10,000ths too far forward a bit. So we're going to do another 2 passes, and we won't take any off this near side of the bearing. Right, get on with that. Just thought as an indication, that's the ink level I'm putting on. They're in a lot. I sat and watched the video by Muller Nick last night again, where he is scraping in a sort of tapered bearing, for want of a better phrase, from a Myford cylindrical grinder, and he puts it on with a roller, going around to avoid any streaks running like that, which is obviously going to be far more critical on a tapered roller, well, tapered bearing, where the one cone fits inside another cone. It's like a sleeve. With this, I'm just swirling it with my finger, so it's perhaps not as even as it could be, but there ain't much on there. There's a little bit more on the tail end because I'm not working on that just at the moment. So I'll stick it in the overhead and do another print. Excuse my bonds. And I'm only doing that kind of rotation. So that's the face I've just scraped. As I say, just to try and move, I want the front end of the spindle test bar around about 3/10 that way. So you can see the areas where it's in contact. I'll remove those and we won't be far off, I don't think. And the rear one I've barely touched. Alrighty. That's at about, I think it's 4 hours now. The alignment's absolutely spot on in terms of front to back, up and down. So now I am literally going for points of bearing and trying to do away with some of the sketchy looking scratchings. See, it's fairly hard on this side, so I'm just going to take it down and spread the contact points round.